Yesterday that I'd leave a video going over example number 5. We did a question like this a few days ago, example number 4. We did that by fill in the blank style. This time I had asked you to try practice writing this on your own, and the goal here is to find a value of x and make an angle measurement justification to explain why a and b are or why they are not parallel. So notice the one thing you can't do, the 4x plus 6 and the 134, those are alternate exterior angles. If I already knew the lines were parallel, I could write 4x plus 6 equals 134. But I don't know that they're parallel, so I can't write that equation. I have to start with an equation that I can trust, regardless of whether or not A and B are parallel. And so that involves taking advantage of these two angles here, which form a linear pair. So I know that 4x plus 6 plus x plus 14, I know that that equals 180 because of the linear pair. All right, so now I can do some algebra to solve for x here. So solving for x, we get the following. So I'll just combine my like terms. The 4x and the x make 5x when you add them. The 6 plus the 14 makes 20, and that's equal to 180. So solving for x, first we get this. Then if you subtract 20 from both sides, then you get, what would that be? 5x equals 160. Or if you divide the 160 by 5, you get x equals 32. Now, the reason that that's so important, I can substitute that back in order to figure out what the actual measures of these angles are, and I can make a comparison with the 134 in order to make my decision about A and B. So if you take 4 times 32 and you add 6, so literally here, 4 times 32 plus 6. If you do that, you get a 134 degree angle right here. And if you take 32 plus 14, here that gives you a 46 degree angle. And we knew those two had to make 180 degrees when you add them because we have a linear pair. But now notice, because of the value of x that we got from the linear pair, I can see that this angle here really is a 134 along with this angle here. So now I can see that I have a pair of alternate exterior angles that are congruent, and that will force lines A and B to be parallel. So I can say, knowing that x is equal to 32, substituting into the 4x plus 6, substituting into this angle up here, which is the alternate interior angle, results in a measure of 134 degrees. So, but then notice there are alternate exterior angles that are congruent. They're both 134. There are alternate, and you can abbreviate, exterior angles that are congruent. They're both 134. So what that means is A must be parallel to B. So line A is parallel to B. And you can use symbols. It would be perfectly okay here. If you don't want to write it in words, you could say A is parallel to B. You can use the parallel notation. That's fine. So understand, if we had plugged in our value for x, if this angle had been something other than 134, let's say it came up to be 133 or 132 or maybe 137 or 138, if these two alternate exterior angles are not congruent, then I would have to conclude that the lines aren't parallel. So the bottom line behind a question like this, you want to start by either using a linear pair, or you could use vertical angles in order to get you a value for x that doesn't depend on the lines A and B, and then you can use that value for x in order to find an angle pair, like alternate interior, alternate exterior, corresponding same side interior angles, and you can use that relationship to make the conclusion about whether the lines are parallel or not.